Okay, so this is section 2.2. Today we're going to talk about quadratic function objectives. We're going to be talking about parabolas. We're going to talk about characteristics of a parabola, graphing parabolas, determining quadratic functions' minimum or maximum values, and then solving problems involving quadratic function min and max values. Okay, so the first thing, so this is a standard equation of a quadratic function, which is basically a parabola. The A represents whether the function opens up or down. The H and K represent the vertex, which would be like the ordered pair that corresponds to the max or the min. And I guess that's it. So, and then we also have an axis of symmetry, the line that's symmetric, that's x equals h. Okay. And then I wrote over here too, because we're going to do an example in a minute here. Okay, so first thing we do is we decide if it opens up or down. This is what I actually have over here. By looking at A, then we determine the vertex. Then we determine any x-intercepts and then any y-intercepts, and then we go from there. So we're going to do this example. I actually have it written right here so I can kind of go through the steps. So I think I'll just go ahead and move this up as I go through it here. So the first thing I would do is decide if it opens up or down. So if I write this, I could just put a -1 here, and that tells me that A is negative. So that means it opens down. Now parabolas look kind of like this. They either look like this or they look like this. If A is negative, that means it's going to look closer to this. If it's positive, it's going to be open up. So this tells me it's going to open down. The next thing I'm going to do is I want to find the vertex. So I want to find HK. So if you compare this with the original function, which it's up here, it's right here. I think I'm going to write right next to it. And this is what we have for our particular function. Okay, so by looking at this, we could tell h is -1. I'm sorry, h is 1. And then k is 4. So our vertex is going to be hk, which is 1, 4. Okay, so that's the first part. Okay, now we're going to find the x-intercepts. The way we find the x-intercepts is we set the function equal to 0. This is the same thing you do with lines. You set y equals 0. It's the same idea. Okay, so step 3, I set f of x equals 0, so I'm just going to set this equal to 0. And then I want to go ahead and solve it. So I'm going to first subtract 4 from both sides. They did it in the PowerPoint as well. I'm doing just a little bit different than how they do, but it's okay. Okay, and then what I'm going to do is I'm going to divide both sides by -1. That way I give her this -1 here. Okay, and now we do the square root property. The square root property says if x minus 1 squared is equal to 4, then x minus 1 is equal to plus or minus the square root of 4. So this is plus or minus 2. Okay, I'm going to go back over here because I'm running out of room here. So now I'm going to go ahead and solve for x. So x is equal to 1 plus or minus 2. And that gives us two answers, 1 plus 2 and 1 minus 2. So we get 3 and we get -1. So our two x-intercepts are 3, 0, and -1, 0. Okay. So let's go on to the next one. The next thing we're going to do is we're going to find our y-intercepts. To find our y-intercepts, what we do is we set x equal to 0. I'll put that right here. So to find the y-intercepts, I'm going to find f of 0 So I'll plug in 0 into this original equation. So I get just -1 squared in here, which I'll simplify. That gives me 1. So I get -1 plus 4, which gives me 3. Okay, so the y-intercept, where it hits the y-axis, is 0, 3. Okay. Now we want to go and graph it. Okay, so let me go ahead and show you the graph here. The first thing we look at is the vertex. The vertex is 1, 4, so that's right here. And then we looked at the x-intercepts. The x-intercepts were 3 and -1. So here's -1, here's 3. And then the y-intercept was 3, and that's this point right here. So now we have enough to graph the function. Okay, in the next video, I am going to talk about another way we can look at functions, another way we can find vertexes, I should say. And that's by using this formula -b/2a, where this is a is what's multiplied to x squared, b is what's multiplied to x. And then we plug that in to find the other one. So I'm going to start with this with the next video.